Salam sejahtera and a very good day, everyone. I hope you guys are doing fine and in the best of your health wherever you are. So, let's start our online learning today with the topic Computing Architecture for Virtual Reality. As you can see from this figure, basically this figure is representing the VR system architecture. As I always put this figure in the previous chapter, generally we will get the task from the user and how this user gonna interact with the VR environment over here. Of course, the user will need to interact through this input device. The user will need to enter the data to this through this input device, and then the data from this input device will be sent into this stage, which is the virtual engine, or we can call this process as the computer rendering pipeline. From this stage, it will select the related software and also related databases to use, and then it will send back to this virtual engine, and then from this virtual engine it will send back through output devices, and then through these output devices it will feed the result to the user. So the component that we're gonna cover today is inside here. We're gonna cover about virtual engine, or the process that is called as the computer rendering pipeline. So let's find out what is virtual engine and what is rendering pipeline in the next slide. The virtual engine. So what is this virtual engine, or you can call this in a short form as VE. Okay, you can call this virtual engine as a VE. And here are the definition of what is virtual engine. Virtual engine can be defined as a key component of the VR system, which read its input devices, access task-dependent databases, update the state of the virtual world, and then feed the result to the output display. So basically, this virtual engine can be considered as a main element or main component of the VR system. Any complete VR system must have this virtual engine. And what is the role and the responsibility of this virtual engine? Basically, the role or the purpose of having these virtual engines in your architecture is that it will read the input devices. Okay, its task is to read the data coming from these input devices and access tasks in the database, and then we update what kind of VR activity to be used, and then once they select what kind of VR activity, lastly it will send the output display to be experienced by the user. And here are some of the examples that we can consider as a virtual engine. It's abstraction because there are no specific things that we can consider as a virtual engine. So let's see some example of virtual engine here. Okay, it can mean one computer. It also can be referred to a several co-located core in one computer. It can refer to a several co-located computers, or it also can be referred to a many remote computers collaborating in a distributed simulation. So we can go one by one here. Okay, this virtual engine can be considered as only one computer. You can use only one computer to represent the virtual engine, no problem. It can be only one computer. Or you can refer this virtual engine as a several co-located core in one computer. Co-located here means that share the same location at the same place. This is co-located. Share the same location or at the same place. So a number of several core components or several core means component inside one computer also can be considered as a virtual engine. Besides that, you also can consider this virtual engine as a several co-located computers. This means a several numbers of computers at the same place. Or you can refer this virtual engine as a many remote computers collaborating in a distributed simulation. It means that many computers that can collaborate or work together through remote or through networks. As you know that the virtual reality environment is a real-time characteristic, so it requires a very powerful VR engines. Why is why we need this VR engine? This is which is very powerful because we need to ensure that it can support the fast graphic and haptic refresh rate, which is around 30 frames per second for the graphics and also 100 of hertz for the haptics. This is why we need this a very powerful VR engine because it needs to support the graphic and also haptic refresh rate that can cover this type of numbers for the graphic and also for the haptics. Beside that, we also need to ensure that the VR engine can support the low latency. We need to achieve this low latency. I hope you still remember what is latency that we already covered in the previous chapter. So basically latency here means that the delay time between the action in real life and also the output in the VR environment. So we need to make sure that it's low as it can for this latency. Make sure that it's less than 100 millisecond to avoid simulation sickness, or we can call this as a discomfort. And when the latency is high, okay, what is the impact if we cannot achieve this low latency? Of course, it will affect the user performance inside VR environment. It will degrade the user performance in virtual reality environments. Means that the performance of you or as a user in this environment will drop. Beside that, it also can affect or impact in terms of the simulation sickness. You will feel sickness or dizzy due to this delay time in the virtual reality environments. And beside that, of course, it will affect the sense of presence as well. Okay, it will decrease the feeling of being there in the virtual reality environment. You not feel real in that virtual reality environment anymore if you cannot achieve this low latency. So at this stage, the architecture that play an important roles in this computing architecture is the rendering pipeline or is a graphic pipeline. There are two names here. Either you can use rendering pipeline or graphic pipeline. So basically this rendering pipeline or graphic pipeline is a sequence of steps. Okay, there are a sequence of steps that we're gonna cover today inside this graphic pipeline. So let's find out what is this step in the next slide. What is graphic rendering pipeline? So based on this definition here, the rendering first. What is the meaning of rendering? So basically rendering means that the process of creating a 2D scene from a 3D model. So this is the process or method of creating a scene from a model. First we get the 3D model and then it will need to change into the scene, 2D scene, so that it can be seen by us through the screen. So generally rendering is the conversion from a scene into an image. Or another way of rounds, basically this graphic rendering pipeline is the conceptual models that describe what are the steps needed by a graphic system that they need to perform to render a 3D scene to a 2D screen. So what are the steps that needed for us to see a things from the screen? So here are the steps needed to process this graphic rendering pipeline. It have the step of application, it have the step of geometry, and also it have the step of rasterization. After that, after they gone through these three steps, so we can see the graphic through the screen. Okay, we cannot see the 3D graphic directly from our eye through screen. So what computer need to do is that they need to convert that 3D scene into what we see from the screens. Once a 3D model has been created, for example, if you create a video game, for example, or any other 3D computer graphic animation, the graphic pipeline is the process that turning that 3D model into what the computer can be display. And here are the steps inside this graphic rendering pipeline. Okay, it have application stage, geometry stage, and also rasterization stage before it go to the screen for us to see. So what we will learn today is that what happened inside this stage, what happened inside this stage, and also what happened inside this stage. So let's find out what happened inside application stage in the next slide.